And for this particular summary, I'm going to suppose some values, which is this is a manufacturing entity. And its capacity is 300 units. Its fixed cost is $5,000. The variable cost per unit is 30, and the selling price per unit is 70. So let's perform the CVP analysis. So alongside these values, I'm going to present what we call the table of units produced and sold, total cost. So it's the X, and total revenue, and the total cost table, right? And we'll use this table to draw a graph considering the total revenue and total cost. And from there onwards, we are going to interpret that what this graph of CVP analysis encompass. Now, in our physical lecture, I told you people that CVP analysis through graphical method is particularly about the two equations, the total revenue and the total cost. We plot the total revenue and the total cost together, and with the combination of these two equations on a graph, we get regions of a profit and regions of a loss and a region of a break even. So if I talk about this total revenue, the total revenue is simply equal to whatever is your selling price multiplied by the units you produce and sell, right? So this equation right here, this equation 1, basically represents the total revenue. Similarly, the total cost corresponds of two components. The one is the fixed cost, which is added with variable cost multiplied by unit produced and sold. Let's call this equation 2. So what we are going to do is we are going to present these two equations on a graph, and then we'll perform our CVP analysis. Now, for this matter, whenever you see this term right here, which is the capacity basically means that that is the maximum output that entity can produce given some resources, right? So in this case, the maximum unit produced in this case is 300. So I'm going to consider some value. I'm going to select a scale, and each scale represents the unit produced and sold equal to 25. So I'll start with a 0 origin when the unit produced and sold are 0. Then I'll move towards 25 and then 50. So basically, I'm using the increment of 25 units for each scale. So I'm going to extend that till I reach the maximum capacity of 300. And here you go. So this row right here represents the unit produced and sold. And I'm going to highlight that. So the yellow one basically represents all the units which we can produce till the maximum capacity, which is the maximum capacity. So this is the capacity, and this is basically minimum or the least values we can produce, or no value we produce, right? So this is the maximum, this is the minimum now. For these units produced, we are going to calculate the total cost and the total revenue. So how are we going to do that? So I'm going to use this equation and to calculate the value of total cost, total revenue, and then I'm going to use this equation right here to calculate the value of total cost. So it's something like this. So the equation is basically, which is equal to this selling price right here. Now, mind you that whenever I use some particular cell time and again in calculations, I'm going to fix that. And in Excel, you can fix that through F4 key, which is on the top of the keyboard. So I'm going to press F4, and the dollar signs appear. This means that this cell is fixed for all the cells you're going to calculate here onwards, right? So the next one is I'm going to multiply the number of units produced and sold, which in this case I'm considering it as 0, and click enter. So when I produce 0 units, I sell 0 units, so the total revenue is 0 units. So it's like that. Since we fixed the value of selling price, then I can extend this cell like this, and this will basically calculate the value of total revenue for all the cells. So this means that when 0 units are produced and sold, the total revenue is 0, and when the maximum units in this particular case, which is equal to 300, once they are produced and sold, we get the total revenue of 21,000. Similarly, for the total cost, I'm going to repeat the same procedure for this equation right here. So I'm going to start with a bracket, and then again the fixed cost. Once again, I'm going to use this fixed cost value time and again for each and every cell to calculate the total cost for all these units ranging from 0 to 300. So I'm going to fix it once more, right? And then bracket, and then I'm going to add another component, which is the component of variable cost times the unit basically produced and sold. So here you go. That's the variable cost per unit. I'm going to fix that value again because this cell will be again used for all the calculation along the way. So this is fixed, and I'm going to multiply the number of units for this particular cell, which is basically 0. And bracket close and enter. Now, this means, this basically proves the point that fixed cost is independent of the units produced and sold. So in this case, if we consider 0 units produced and sold, the total revenue is 0, but the total cost is 5,000. Now, what does that mean? So if I consider this equation right here, right? Here in this equation, if I put the value of unit produced and sold 0, right? So this means that the variable cost will also be 0. But the fixed cost in this case is not 0, it's 5,000. So if the unit produced and sold are 0, still we have to bear some fixed cost. And that's why it's called a fixed cost, which is regardless of the fact that if you produce 0 quantity or if you produce till the maximum extent. Now, what else I'm going to do is I'm going to extend this cell till the end, which is the 300 unit till 300 unit, and it will result something like this. So this means if I sell and produce 0 units, so the total revenue becomes 0, the total cost is 5,000, and if I produce the maximum of 300 units, the total revenue is 21,000, and the total cost is basically 14,000, right? Now, if you review this table, so I'm going to represent this all with green so that it is consistent. Here you go, and this one with red. So this yellow row represents the number of units produced and sold. The green one represents its corresponding total revenue, and the total cost corresponds to the values to the total cost value with reference to the number of units produced and sold. So let's bring it in center. Now, if you observe this one, you will notice that if I produce 25 units, the total revenue is basically 1,750, but the total cost is 5,750. So basically, this entity is in loss if they produce and sell this much of unit. But as you move along the way, the margin of difference between the total revenue and total cost basically decreases, right? So if I move to this point here, it's 5,250. Here, it's 7,250. Previously, it was for these values right here. But if I move towards this point right here, 125 unit, here notice the total revenue value and the total cost revenue, they are basically equal. And this is what we call the break-even point, right? This is basically the break-even point on which the total revenue equals the total cost. So this is the point where you have no loss, and no profit, right? Now, this point is real imperative one, because if you consider any value beyond this point, that will result in profit. But if you consider producing or selling any unit below this point, that will result in a loss. Now let's understand this thing through a graph, right? So I'm going to represent these three components through a 2D line graph. It's something like this. So I'm going to select insert, and then the line graph, and this table will appear. And once I double click this table, on top right corner, I'll get these three tabs. So I'll select this one, which says the select data. So now I'm going to tell Excel to plot some of the variables and something like this. I'm going to add one of them, and I'm going to tell Excel that in the first one, which says the series name, I'm going to take the series name total revenue and its corresponding values like this, and I'll press OK. And similarly for the next one, I am going to tell it once more the title total cost and take its value that range from 5,000 till 14,000 right here. Okay, and click OK. Now this one is the y-axis, this one is the x-axis. This one represents the what we call the net income value, or the total revenue value in this case, right? And this one basically represents the unit produced and sold. But as you can see, the unit produced and sold range from 0 to 300, but here it's written from 1 to 13. So I'm going to change this one right here. So for that, I'm going to click this little box right here, click edit, and then tell it to pick the value of x-axis like this, okay? And now it's okay. I'm going to press OK. And let's arrange this graph a little bit. So I'm going to add minor grid lines and major one too. And then I'm going to do the same right here. So here you go. Once again, I'm going to know that what are particular values on these two curves. So the total revenue and the total cost equations, which are basically represented on graph. So I'm going to do that. Select the data labels. So now how to interpret that? So at this point, I'm going to stop part one of this summary. And in part second, we are going to discuss this graph right here.